I'll introduce Victor. He's a developer advocate for Confluent. Confluent is the guys who are responsible for Kafka. We got anybody using Kafka now? People wanting to learn about Kafka. I hope.
First consumer up.
You got your first consumer up and running?
Yeah.
On Kubernetes?
Not yet.
Not yet? Well,
that's why we're here.
You got to learn about it today. All right. And then, as always, I like to give our speakers a gift, a little token of our appreciation. I hope you like bourbon. So you've got, I know you're flying a lot, so I made sure to get you the samplers instead of a full bottle.
Thanks so much.
So, and with that, yeah, I'll hand it off to Victor.
Thank you. All right. Hi, I'm Victor. Okay, great. Where's my, where's that with the clicker? Have you seen it? Oh, yeah, there's the clicker. Okay. All right. So, I just came back from San Francisco, literally just like yesterday, right here. We have this event that's called Kafka Summit. This is where all the people around the world who care or do something with Apache Kafka or some other things around streaming, stream processing, and all the stuff they gather around. In San Francisco, it was 2,500 people event. It was pretty big. I was pretty excited. I was a part of the team who helped to organize it, and I was there to hosting some of the sessions. And also, I was speaking about the things that I like. So about how we do run Kafka in Kubernetes, like where it came from, and like all this stuff. Yeah, my name is Victor. I work as developer advocate. Confluent, founded by people who wrote the Kafka in LinkedIn and open source it, and they decided, okay, so maybe we can start some of the venture around this. So, and 5 years after, we're running the best managed service for Kafka. We're running the leading distribution of the streaming platform based on Apache Kafka. We include some of the stuff in open source. KSQL, for example, it's our spoiler a little bit of, I don't know if I'm getting recorded, so I'm not gonna say this. we're actually thinking about the concept of streaming database, how to make the kind of traditional database where we have a state store type of thing into something that moves and also allows to do some processing in between. I'm going to be touching some of these bits today in my demo, so you will understand what I'm talking about. Yeah, and like I'm part of the team that's responsible for talking to developers, see what they live and breathe, and showing what we can do and what they can do with our stuff that we do. So. Yeah, this is pretty much it. So if you have a Twitter, because it's important, I'm going to be using Twitter today as a demo. If you don't have a Twitter, there would be no demo. But we'll see how we work around this. Yeah, this is another fun definition of my job. So I build all sorts of Hello World applications. Usually they're very highly scalable, highly available. Cloud, Kubernetes, this is what we do there. Like everything is highly scalable and highly available. So I like to start talking a little bit about, yeah, first of all, unfortunately, it's not like Kafka 101, but I will try to explain for people who don't know what Kafka is. So Kafka is, so first of all, it's a not messaging system. I heard some people were talking about this, and I consider this is a crime when the people just talking about, you can quote me on this. Kafka is what we call a event streaming platform or streaming platform. Which includes multiple aspects. Kafka has more similarities to distributed database rather than like messaging system. It has only thing that common with messaging system is that it pops up pattern accessing some of the data. So the Kafka is the implementation of the concept that called log. So essentially it's the file where you're writing in the end of the file and reading from the beginning of the file. There's no random access. You're always writing to the end of the file and reading from the beginning of the file. It looks like a queue, so that's why people consider this for a messaging solution. However, Kafka, when you're reading message from this side, it doesn't remove this from this log. Log is the sequence of immutable events, and you cannot change this. If you want to change this something, you need to send another event. So the good example of this, you have an argument with your significant other. You said something, you cannot change what you said, right? You need to send something to amend this, right? You send another message to explain, and it would be depend on the receiver side how fast it will consume this and understand, and will make any like decision based on that. So think about this similar aspect in Kafka. Kafka is also highly available and highly scalable system. So these files, these logs, they are actually stored on multiple machines, and you can actually group these files in this thing called topic. With this aspect of scalability, it actually inherits a lot of similarities from distributed databases, like any traditional, already traditional NoSQL databases, where you have a concept of consistent hashing in the way how your data is distributed across multiple nodes of your cluster. So this is Kafka 101. But this is just the storage. It's just the storage aspect, so that's why people are actually missing a couple of the bits when we're talking about Kafka. Kafka also includes this concept of connectors. It allows you to pipe different data sources in and out. If you need to bring data from some database, there's a connector that can listen the changes from your database and propagate these changes into Kafka plugin. If you want to get this data out of Kafka somewhere, for example, Elasticsearch, you can easily do this with connector that can read the data from Kafka and push it to Elasticsearch. The cool thing about connectors is that you don't need to write your connectors. There's plenty of connectors. It's just a part of overall ecosystem. And the third part of this thing that we call streaming platform is the stream processing library. So Kafka ships with the Kafka Streams library. It's a Java library that you're using, or there's like Scala DSL for this, that you're using to write your stream processing application. You don't need to run other clusters. You don't need to run like Spark, Flink, all this kind of stuff. You can write just simple Java apps. After a certain time, when we start, talking to customers, talking to people, and things like that, we realize that there's not Java ecosystem is pretty big, and there's a lot of people who write the stuff in Java, but there's a lot of non-programmers who wants to do stream processing. So this is why we decided, okay, so let's use this foundation. This is what you can say, like eating our own dog food, but I like to say drinking our own champagne or drinking our own bourbon. This stuff that we realized that we can use this to build something more high level. So we built this KSQL, which is the streaming SQL for Apache Kafka. So you're using language like SQL to write stream processing applications. In this case, you don't care about Java. You don't care about how this SQL will be executed. You know that there's a stream of data that is coming through this connector, and the stream of data will be processed using this SQL itself. So this is something that I will demonstrate today, and how to run this in the highly scalable fashion. So now you know Kafka. So this is the foundation that you need to know. So the first thing that people are starting to do, they go to kafka.apache.org, download the tarball or zip there from there, or maybe they go into Confluent.io and download our distribution. So this is what I called like very beginning, when they start this journey, how they start running Kafka. They starting this Zookeeper. Kafka depends on this, Kafka's distributed system depends on another distributed system, which is Zookeeper that stores some of the metadata. So you need to start Zookeeper first. You need to make sure the Zookeeper is up and running. After that, you start in Kafka, and after that, you start writing your apps. Very soon, people realizing that, okay, so when we try to run these clusters, we need to execute this stuff like over and over and over and over and over again. So we need to come to some sort of automation. Usually they come into writing some modules. We officially support Ansible playbooks for all this stuff. So and this is why kind of like it's our choice of automation that we support. There is some open source project that support Puppet, Chef, etc. There is some of our engineers, my colleague, he wrote a kind of like a Terraform script that allows you to also do similar thing in AWS and run the Kafka there. So it's a little bit better. Now, another thing that people start using, okay, I might have all my dependencies, including operating system, including some other configurations that I need to pre-configure. So all the stuff that they might be doing with this configuration management system, they want to like back in. So We also built a lot of connectors. There's no official, believe me or not, there's no official Apache Kafka Docker image. So this is what we built, and people use our Docker images as official Docker images. Even they might not need to use any part of our platform, but they can use just Kafka and Zookeeper, and they're good to go. But with containers, you need to have something to manage this. It's at the bigger scale, right? So you're not deploying these containers manually. You start using things like either Docker Enterprise with the Swarm, or you start using something like Kubernetes, and you're still kind of like rolling this stuff yourself. I think in the kind of Homo erectus Kafka's operation individual, I would say this cloud would be a place where you stop thinking about infrastructure at all. You just want to write your apps. You know that there's concept of like topic, there's some topic, and infrastructure would be responsible for scaling your loads if you have increased load, or scaling down, so it will decrease your bill. Plus, it should bill you not on number of nodes, as we have this kind of license model per if you're deploying this on-prem, but per usage. Like if you don't use this, you don't pay. This is quite logical. So this is why a couple years ago we started offering this Confluent Cloud, which is a managed Kafka solution. So my colleague Ricardo wrote the blog post about comparing different managed. There's actually few managed Kafka solutions, and he definitely is biased, of course. But like I found a very interesting point where I can translate this into the things that I'm going to talk next. So in many cases, when you're managing some of the software, the challenge is not about management itself, but in gaining experience. So over the time, during this certain time when you're using some software, you're gaining this experience. You're learning something, maybe you go to training, maybe you're reading books, and you live, you learn, you going through some mistakes, you participating in meetups, exchanging some of the knowledge and things like that. But it really depends on if you get paid for this, right? If your employer okay with you doing this kind of like research on the time, it's amazing. It's a perfect time. But if they they want you to build apps that will be serving the business and bringing the value into the company, those kind of stuff, maybe you should like focus on something else, like building this app rather than like a jungle of the infrastructure. Same thing with the cloud. There's a lot of kind of cloud providers that kind of sort of, oh, we have this managed service, but you need to decide what kind of instances you need to choose. You need to decide what kind of storage you need to choose. You need to decide how you will distribute this data between multiple zones in case of you need to do results and things like that. And after that, only thing that they do is just kind of like deploy this package for you. That's it. There's some cloud providers that eliminate this, and they just give you simple API. And the thing that we will learn over the time, that user experience that we're getting people in the cloud, they actually like it, and they want to have this on-prem. But on-prem right now, we can say, oh, you can get this RPMs, you have Docker images, but like, knock yourself out. You can do this yourself. And the customers that came and saying that we actually want to have same experience. We don't want to think about it. We don't want to like have in-house expert that knows how to run Kafka. So like, can you do the same stuff you do in the cloud? And we're pretty sure that your cloud team is not extremely big, because usually all smart people, they're lazy people, they try to automate this and they don't want to repeat their tasks. So that's why like our cloud started with a team of 5 people serving like hundreds of like production Kafka clusters. When the people get paid, there's SLA, there's contracts and stuff like that. The way how they did this, they have tremendous experience running Kafka in general, and they have experience on automating this kind of stuff. So they simply automating certain things. So we decided, okay, how we can bring similar experience to our customers. And which brings us to another key player today, right? So this is where you learn that this is something big. Google gives you this, and the Google might not be mistaken. Google is always right, things like that. There's like people start jumping to this thing, like swiping credit card, and hey, let's go, more computers. And there was actually a conversation with one of the customers before I was in this kind of like a evangelical role. I was in professional services in Confluent, so I was working with multiple customers on deployments, on support, on all sorts of things that related to Kafka and Confluent platform. And people were saying, "Oh, we actually look into this like a container thing and Kubernetes thing. Like okay, good. Why are you looking for this? Oh, we want to like save some money, so we will not run this in our data centers." And if you have like a small deployments, you're starting slow and you're getting like onboarding, it would be much more cheaper if you're running like, your own data centers, your own hardware, you're paying electricity bills, paying water bills, and so far and so on. But when you go into the cloud world, we learned this also hard way because we were fully on-prem company or selling licenses. When we switch our mindset to cloud mentality, there's all sorts of different things came into play, like when you're running like thousands of the clusters for the customers, you start looking to build, and you start looking like what kind of cloud provider, because we're not building our own cloud. We're running on every major cloud provider. We're running in AWS, we're running GCP, we're running Azure, and we just want to give this flexibility for our customers who want to run on different clouds. They might be some retailer that don't want to pay money to Amazon. So that's why they don't want to run on Amazon their cloud workloads, because they just they are compete with Amazon. And even though retailer versus cloud, it's maybe not the same business but the same company, so people don't do that. So yeah, the cloud economy is different. So it's why we start continue to paying money to Kubernetes. Another important slide, some people saying like I'm pronouncing Kubernetes funny. I'll give you some of the other options how we can pronounce Kubernetes. My favorite one probably is Kubernetes. It's the Kubernetes. It's a kind of like reference to Clubber Lang from Rocky 3.
That
so
Corny Pig is a great Twitter.
Oh yeah. The Corey Quinn is an amazing guy. He's like changed my life. Find this video when he's talking about dev of enterprise software salesman. Amazing talk when he's talk about the all things on enterprise software. Anyway, so let me ask you a few questions. We learned that not many of you maybe know Kafka, but what about actual like small apps? Like how many of you are running apps today on like a fully stateless, just the web apps? I just keep your hands up. Who thinks it's a good idea? Okay, why you don't think it's a good idea?
No, that's right.
You also convinced it's a good idea.
Skip me.
Okay. So I think it's a good idea either, because the containers, like when they run the ephemeral like web app that has some static stuff, it's just like perfect. But if you don't scale this, you don't have any state, just scale and everything good to go. How many of you are running stateful applications? Okay, and who thinks it's a good idea? Okay, this is good. We still think it's a good idea. Usually people kind of like hesitate. They running this, but hey, I'm not sure. What kind of type of workloads you running, like stateful?
I run a GitLab instance on Kubernetes, so that's pretty stateful since it stores data about your repository and your issues and projects.
Yeah, what kind of type of storage they use?
It's root storage, which uses the drives that are attached to the nodes. So it's pretty simple setup.
Mm-hmm.
It's actually a homegrown cloud. We're not using Google Cloud or AWS. I just rolled it onto our on-prem servers, and that's how I run it. And I also wrote a couple of applications with databases that run on Kubernetes.
Mm-hmm. What about you?
Yeah, Postgres. We're on Postgres inside Avery. Inside Kubernetes with some volume storage.
What about you?
PostgreSQL.
Okay, so right now the situation is actually changing. Like when I start like talking about this talk and where we start when we start like building the Confluent Cloud itself, was like a little bit hesitation. Some of the stuff was not super maybe stable. Some of the things that was available in Kubernetes, like there was no like dynamic provisioning, this kind of thing. It was like before 1.6, I guess. But now the things are changing, and it's fine, right? But there's a couple of things usually the audience needs to decide, or people who needs to think about, like moving stuff into Kubernetes, is that it's not just simply you package your software in container and just ship it to Kubernetes. So, and okay, I'm done. It's cloud native. Okay, get the flow. No, it's just a change the way how you would manage, how you would monitor, because like in some of the vendor software that you're using for years, they might not support containers, they might not support Kubernetes. Now you need to look for the solution that support this way. You need to rewrite your application that it will be supporting some of the kind of like a patterns of like monitoring of the stuff and things like that. So specifically for Kafka and specifically for some of the network application, distributed systems, they usually put some of the additional requirements on the network and the way how they communicate to each other, some of the how they form cluster and how they communicate to external clients. I'll give you an example. I talk a little bit about this thing called consistent caching algorithm, which is basically one of the variants of this algorithm used by many distributed databases. Is just the way how they place data on particular shards on different nodes. So they take a key, they apply some sort of hash function, and based on the hash function, they know that a particular partition or shard or particular node that will hold this. So in this case, usually if we're talking about distributed systems, usually client needs to communicate with all nodes because client knows this hash function algorithm, and usually it's much faster to calculate this like hash function than just go into some discovery service, get information from it, and after that the discovery service needs to know how to find this data. So usually it puts some of the additional, you cannot just put everything behind some sort of firewall and the protocol, how Kafka uses protocol. Kafka uses TCP/IP. It's a stateful protocol. We need to like maintain connection. So your network infrastructure needs to support this. And it's okay if you're running apps internally. Kubernetes has like simplified model to discover other services when you're running this internally. Or even on the same namespace, so you don't need to even think much here. If you need to get external access, now you need to think if you need to use load balancers, what type of load balancers, how to provision this. If it's a full external, you need integration with DNS, that might be integration with cloud DNS, so far and so on. So there's a lot of things that need to be considered and need to know, not only from the Kafka perspective, but also from perspective of maintaining this Kubernetes infrastructure. The storage, it's also very important and interesting thing because since Kafka, it's the file, and this file is multiple files distributed across multiple nodes, you need to have a storage to store this data. And as you give the example that like using one type of using Rook, there's some people who use like Gluster, some people use NFS, some people use AWS storages. Some people use Google Cloud Storage. So all these kind of things needs to be kind of sort out for you, or like at least support it in some way when you move this kind of stuff. And important thing, as you can see, it's a 4-item in my list because it's the most important thing, and the most things about security is that people usually think about security in the first place, right? Wrong, of course, because people usually try to get the running because security is hard. Security is difficult, and this is something that people needs to we'll figure out this after. So let's get this running, this distributed stuff. We don't understand how to do this, and after that we will figure out security. And usually this after that never happen until there's some accident, data leak, and we need to think about security. So specifically like security configuration, how to provide encryption of the data in motion and encryption data or like authorization of the clients, and notification of clients, and entitlements, and all this kind of stuff. In this particular part, and I'm saying again, the security configuration for Kafka in the context of Kubernetes, if you're running this in Kubernetes. So there's a kind of like two like thought leaders in the world. How many of you heard about Kelsey Hightower? All right, the Kelsey Hightower once famously, or maybe unfamously, said that actually I like this tweet because there's actually in this tweet there is very long, interesting thread when he explained his thought, and what he said that basically Kubernetes can meet you halfway in running this stateful workloads. And the second part is responsibility of the system administrator or SRE that knows domain of this particular system. If we're talking about database, it needs to be expert in the Postgres because there's some things that the way how the Postgres will do clustering. Same thing with Kafka. The way how Kubernetes does certain things needs to be applicable to the thing how Kafka is doing things, right? So like how to do networking, how to do external access, and so on, or specifically how to do upgrades, for example. There is a we're going to talk about this in a moment. How to map the Kafka's style of rolling upgrades, so the things that the Kafka developers recommend to you to do a rolling upgrade will not be mapped into the way how the Kubernetes will do rolling upgrades. And there's Gwen Shapiro. Anyone heard about Gwen Shapiro? Gwen Shapiro is the Kelsey Hightower in Kafka world. So she's super awesome. She's engineer at Confluent. She did a lot of things. She's contributed to Apache Kafka. She worked as a solutions architect at Confluent. She wrote a book about Kafka. If you need to read the book about Kafka, there's a Kafka definitive guide by Gwen Shapiro. It's the only Kafka book that you ever need. So, and she said, like, yeah, she spent a few days to help someone because she started talking about certain things about Kafka, Zookeeper. So there's some of the components that is a part of domain of Kafka, right? So you cannot just, again, run this in a container and throw this in Kubernetes and run this. But yeah, like Viktor, but you have this title. It doesn't have to be hardware. So this is what we're doing in the first part of this presentation, creating assessments, like everything is, it's terrible, and this is very like a Kafkaesque style of explaining things, right? Let's run some demo, and we'll see how it goes, because demo is always nice because demo don't work. So everything would depend on our. So we'll see how it goes. I just have this like nifty script. So the first part of the demo, to deploy this demo and to deploy all the things around this demo, we will be using Helm. We're not against it. We're not for it. It's something that we use. There's some opinions that there's some security vulnerabilities. If you're installing a tiller, you need to configure properly RBAC, and people usually, the people usually just, where is it?
They fixed that before, though.
So the kind of like allowing to get users policy and things like that. So the next thing is we deploy the tiller because we ship our stuff that we're going to be talking in the rest of this presentation. Let me see if there's a error that I'm expecting. Not yet. We ship this in bundles, and Help allows you to ship more or less complex software that can define the ways how it can be deployed. And when you deploy something in Helm, you're using these like building blocks. You're still using all things Kubernetes pods, the deployments, but Helm gives you a template, right? So you can put different release names, you can put different versions, you can put different images, so far and so on. So it's just a glorified templating engine. You can even use Helm just to generate your template because it speeds up the YAML that you can use the scope control, apply, and it's good to go. I think this is pretty much how all software that you do control apply F, and after that they have this like a long GitHub URL they're doing. If you ever seen, for example, if you ever seen how this YAML from Istio, for example, look like, they pretty much generating this, and after that just keep it in GitHub. Now, there's a thing that we need to deploy after. This is called Confluent Operator, and I will talk about this at the rest of the session. So next component of this is a Zookeeper cluster. So I want to explain the complexity of the thing so you would appreciate, or maybe even feel more miserable. So here's the thing. We use this Zookeeper, which is a distributed database and quorum system that Kafka uses to elect leaders for partitions. So Zookeeper is integral part in order to do broker discovery, because information about brokers also stored inside Zookeeper. Zookeeper is also requires storage. Zookeeper stores data about partitions, about clusters. Zookeeper is also stateful application. So we need to deploy this. Now, and after that, we can start using Kafka. Now, imagine we're running distributed system, which is Kafka, that depends on another distributed system, which is Zookeeper, that runs on top of another distributed system, which is Kubernetes. You don't know where there's the hardware. You don't know where the disks. You don't know if there's actual physical hardware underneath, because like if you're running GCP, GCP runs on top of their custom hardware infrastructure. There is a thing called Borg on top of it, which is the internal system that allows to manage the hardware, and the Kubernetes was highly inspired by Borg. On top of Borg, you have this the Google Cloud Platform layer, and on top of Google Cloud Platform, you have this Kubernetes layer, and this is where we actually run our stuff. It's pretty crazy, like when you're trying to figure out this. A couple years ago, there was a very nice slide when I think it was Jonas Banner from Lightband. He was talking about latency number that every developer needs to know, and he's kind of like explaining like how some of the operation that happens on the processor side of things, and how the latency grows from the processor to registers, to memory, to disk, to network, and so far and so on. And the numbers are growing. Now imagine like with this like pie of abstractions, this is pretty not pretty. Now, what is going on next? Next, we're doing a deployment of my Kafka cluster. So my Kafka cluster will be deployed here, and I'm going to be using 3 nodes cluster. Some of the things that is going on my cluster right now. This is my operator deployed, my Zookeeper deployed, my Kafka deployed. And we're just waiting until rest of the nodes join. And my deployment scripts also checked if the nodes will be successfully deployed. And this is where things getting interesting, because we need to know what does it mean Kafka cluster to be up, right? So if individual node will be up, like the process on the node will be up. And now where we need to know, this is where this kind of like a Kafka operation experience needs to come into play, because in order to Kafka cluster will be healthy, we need to know a couple of things. For example, there's no like leader election scam is going on. There's no under-replicated partition, so there's a metrics that available to consume, and whoever interested in these metrics will be able to read this. So this is how we program our liveness probe to make sure that when we're saying we're ready, we're actually ready. We're not just like start the process. We actually cluster is ready. There's no replication going on. It's ready to do useful things. Now just deploying some of the other components. So this is where we're starting getting interesting. So when we talk to customers, when we talk to different developers, we very soon understand that there's usually not one team that we're doing with Kafka. This is how things start very quickly in LinkedIn, when one team just built a Kafka to do faster ingestions for their Hadoop cluster. And very fast, they realized that the same data can be used in another team. And this is where there's a huge difference between Kafka and another messaging systems, that when data lands in Kafka, and when one of the consumers read this data from Kafka, it will not disappear. So the same way, if you if you're reading a book, and someone reads the same book, you just put your bookmark when you stop. You're not throwing away pages. So if I would use this book analogy with messaging systems, like when you read this page, you just throw it away. Because this is how the messaging system works, and your system administrator start calling you when it sees the messages are piling up. Kafka is more special type of storage. Now, and sometimes, not sometimes, all the times, we might have a situation with different teams talking in different languages. Kafka really don't care what you're putting there. You can put the JSON, you can put XML, you can put images, you can put files. Kafka doesn't care. Kafka only cares about bytes that will be stored, and Kafka will be responsible for storing these bytes for you. But people care. So that's why we need to find the ways how they can communicate in some common language, usually defining some sort of schema, some sort of contract. So we came with this idea of schema registry, which is a REST interface that allows store data about data. Essentially, it's a metadata server. This is like schema registry thing. Also drinks its own bourbon, because schema registry used only Kafka for storage. So now this is example where I have this stateless application, right? So it doesn't store anything on the local, but it uses API approach to store data in Kafka. So if you will trying to, there was very interesting webinar from CNCF when they talk about the storage landscape and storage ecosystem, and there's different types of storage system available. And there's some storage that provide you kind of like a block device. There's some storage system that provides, again, another level of storage. On top of it, you can have a system that provides you file system access, like typical like read-write file system, and there's API-based access. So Kafka uses this file system layer, but schema registry uses this API-based access because it uses Kafka for its storage. Very, very quickly, again, the things are getting very, very, very interesting. Now, remember, I was talking to you about this Connect framework. So Connect framework, it's another thing that uses Kafka as a storage, not only for data, because in this particular case, I will be using Twitter connector that sits there and listens to Twitter firehose, and this is where I need your help. Just gets these tweets and ship this into Kafka. Also, Connect provides the high availability, resiliency, and one of the Connect nodes will go down. The Connect process will restart, and the configuration and data will be stored in Kafka, so it will restart with this data, it will continue. It's another kind of sort of stateless application, but it also uses state inside Kafka. So by itself, you can kill this node. It's fine. It's nothing bad going on. But if Kafka will go down, so data will get lost. So and here I'm deploying my Twitter connector, and I'm good to go. Now this is my processing layer. Now I want to show you how you not only deploy things, because it would be cool if I would just came here and like showing some, like, hey, I'm deploying stuff, and after that, like, what next? Like, why you even show us this? Like, what we supposed to do with this knowledge now? So the KSQL thing is the easiest way to show people who may be far from like stream processing using Java libraries and the Scala maybe stuff. You will understand it's not that difficult. It's super easy, and this is stuff that we actually like liberating stream processing. So the KSQL is another thing. Also uses Kafka for storage and uses Kafka for sources of data. Deploying this, and the third thing is just like small UI that we use to demonstrate some of the things. It's called Control Center, and we're waiting to Control Center to finish deployment. And while I was talking, my deployment was finished, which is perfect timing. Now this is what we have here. So a couple of things is that we have like, oops, come back. Yeah. So we have a Kafka, we have Zookeeper, we have a schema registry because my connector uses schema registry to store some schemas. And my KSQL server also uses this to store some of the schemas. And let's see how it goes. Now, oops, sorry. If I'll do, yeah, this is what I want to see. You can say, okay, so can we see like what is going on there? We see there are some pods. What else? The way how the Kubernetes does the stateful deployment, you need to probably right now stateful set is the mature enough and it's a default standard to do stateful deployments. So I'll do stateful sets. Redundant stand. Stateful sets, and there will be plenty of stateful sets. No, okay. So I need to switch to control here. I need to switch to different namespace. So I'm running this the operator namespace, so that's why my command doesn't show me anything. Okay, so there is a bunch of stateful sets for each individual component here. Kafka uses a stateful set, and Zookeeper uses a stateful set. Everyone using stateful sets here. Reason for this, not necessarily. I just explained you that Control Center, for example, it doesn't. It's a stateless application, but it still uses stateful set. The reason for that is not only about storage, but also stateful network identity, right? So stateful set gives you two things. You need to have you will have a stateful disk identity, meaning that if your pod will be killed and will be rescheduled, you will get the same storage on the other side. And the same thing with your name of the pod. So the difference between these two things is that if you're running this in simple deployment, your name would look something like this. Some of the random generated hash. But if you're running in a stateful set, your name would be always name of this pod will be Kafka 01, regardless if it will be scheduled, rescheduled, or whatnot. So why it is important? I don't know. Different applications might be using these things. Maybe they're okay without stateful set, but in the Kafka world, it was created pre-container world. It was created when everything was running on the bare metal. Not so cloud native, so that's why Zookeeper is super picky if we will change this configuration and one of these nodes will not be available. So Zookeeper will not be able to establish internal quorum, so you will not be able to use Zookeeper to perform this quorum. So that's why Zookeeper requires to have a stateful network identity even after restart. There was actually a few bugs, again, because of this pre-cloud native era. That was resolved recently. For example, Zookeeper written in Java, and there's some the way how the Java talks to DNS and how Java refreshes DNS was, or the way how this Zookeeper client used this was not correct. So that's why sometimes even the Zookeeper node was restarted, or one of the pods was restarted, get new name, but other Zookeeper nodes that try to connect to previous one using IP address that's not available anymore. So this is something that comes into the slide with my troll face and this run Kubernetes t-shirt. Pre-cloud native software needs to change the way how they do things. The good thing is that the modern distributed systems are designed by scrappy startups. And they can't afford a very expensive hardware, so that's why they need to embrace failure. So that's why they design system to kind of one of the nodes go down, things like that. But there's still things that it's not there. So stateful sets, it's important. But too many things to know. I already talking to you about 40 minutes. Where's the simple things? The way how I and we like to see the cloud nativeness is that the Kubernetes is ultimate representation of how the things needs to be done. And Jean-Luc Picard, very famous captain of USS Enterprise 1701D, can say it's my favorite thing because it makes things happen. If you tell the Kubernetes to do something, it makes it so. So this is why the Jean-Luc Picard would load. So you want to say, I want to say change the world that's I have like a 5 terabyte disk, and Kubernetes will go there and do this for you. For example, if I do get persistent volumes, there's a bunch of stuff. See, like I already created this and I asked this, and there's some disk there. But what if I want to go and tell Kubernetes, hey, I just want to get Kafka cluster. I don't care about disks. I don't care about all the services. You go figure yourself. So go figure yourself. If I'll do, and all of a sudden, there's a special type of, there's a special kind of resource called Kafka cluster. There's a, in everything in Kubernetes is a resource. Pod is a resource. Deployment is a resource. Stateful set is a resource. Persistent volume is a resource. Everything is a resource. Also, there's a custom resource. This is where we go into interesting place. So Kubernetes provides the ways how I can do the definition of custom resources. So basically, I'm extending the Kubernetes beyond the point developers extended. They don't care much about Kafka, but we do. So this is why they put us in the position where we can extend their API. So we come up with a few custom resources. In this particular case, we use this custom resource called Kafka cluster, for example, right? Let me show you this, how it looks like. Yeah, so in this case, this is our custom resource. Or we can use Zookeeper cluster. Or for the rest of the components, we call this notion physical stateful clusters. So let's see, if I do I'll see a bunch of stuff. So we define all our custom resources as a physical stateful cluster, and we extend this for Kafka and Zookeeper because it requires some of the treatment, more careful treatment rather than the rest of the components. The rest of the components is very easy. You need to provide their spec, and this spec, all this deployment will behave the same way because of the things what they explain. They don't need anything except Kafka. Once they get Kafka, they really good. Now, let's take a look on this, why I think this, yeah, let me actually quickly show you before I will start breaking things and trying to scale up and scale down. I want to show you quickly why I think this stuff is important, and after that I will switch to some of the other part of the demo. Now, the cool thing is that now this custom resource replies to the standard CLI. I don't use anything except that I don't install any additional plugins in order to control to understand this Kafka resource. And as you can see, there is a standard response on the status inside this custom resource. So you can always go and understand that, okay, so my Kafka is running, and this running is actually not the pod is running, but actual software is running because this is this kind of like extension or custom resource controller that we're going to talk a little bit in a bit, is actually responsible for checking the status of the cluster and reporting updated information and correct information to Kubernetes, so it will get this information out for consumption on the monitoring system, on consumption on just the system administrator, so far and so on. All right. Now, let me start doing something useful. Now, this is where I need your help. I think, let me check. So I deployed this. I should have not, but I think I did. And yeah, my connector. I need to restart this because my connector right now corrects incorrect the Twitter API keys and values. So let's see if we can change this. Okay. So, and if I can go ahead and do make where's my base? I'm trying to re-update the connector for Twitter. Okay, so let's see if it's actually bounced and it's doing something useful. No, so yeah, but let me do this one more time. Oh, I will use some slides while I will be rerun my deployment, because I screwed up some of the connection to Twitter here. Yeah. Okay. Good. Okay. All right. So while it's doing this, I will quickly switch to some slides and we'll talk some of these things. This is going to be what we're going to be using right now, like in a couple more minutes. We're going to be going to tweet about some stuff, and I will try to process tweets in the real time. And during this processing of these tweets, I will try to also like scale up, scale down this cluster and see if we will able to disrupt some of the configuration. I briefly already talked about this, about some of the fundamentals, but what I personally like to think about Kubernetes these days is kind of like a modern distributed operating system. So you're running your apps in the operating system, and the operating system responsible for providing you certain resources, certain network, providing you network capabilities, providing storage, so far and so on. This is how it looks like from perspective of kind of like the application developer. Yeah, let's talk a little bit about some of the things. So the pod is the minimum unit of deployment. Everything is pod, and it's a collection of these containers that share different things. They share the namespace, obviously. They share network. They talk to each other through localhost, which is also a very cool thing. So you can have multiple connectors that one can pre-configure another. Multiple containers that one can pre-configure another. So where it can be used? Usually, combination of the multiple containers can be used to customize some of the software that doesn't have access to source code, or there's different ways to customize it. Software was existed before cloud native era. So that's why, like, yeah, in other options. So there's like a few patterns that allows you to kind of configure and use the multiple containers within pod. There's an ambassador pattern and there is a sidecar. Sidecar allows you kind of system or like one of the containers that don't know anything about, or some other system that you don't want to disturb this container. And this sidecar will be either reporting some of the metrics or configuring something. All the service measures, they work on the kind of like on the sidecar pattern that allows you to the main container will talk to localhost, and the sidecar will be responsible for like distributing this message to other nodes. So, for example, some of the systems, they use this approach to implement security. So your some sort of like software that doesn't support security or configuration of security when you're in the container can have a sidecar that talks to localhost, and after that, this sidecar will be responsible for proxying and like encrypting this result when it's sent outside. There's another approach that's an ambassador that does opposite thing. So again, it's another container that happens on your pod, but let's just say it will kind of represent this the container to outside world. Like one of the examples that I think we can say is that we have some application that also talks to localhost, and I think some of the dependency or particular host we can impersonate and make sure that this application continues to work, and we will be kind of doing actual work that this application will expect. Like, for example, I was just trying to come up with some example. Like, we have some application that written in a way that it use some another service that runs on the same machine. But since we moved to this to container, the service is not available. So that's why we can have this ambassador that also will represent some of the API calls that this one container uses to connect to another. And they share file system. So let me see if it's good when everything is automated, right? So I can very easy start over while I'm talking, and this heartless machine will do the thing for me. The storage thing. We have the concept of persistent volume. Persistent volume, it's something that would be attached to a particular pod, and this something will be available to writing files. Usually, it is a kind of some sort of mounting point. The way how the persistent volumes and persistent volume claims work, I have on the next slide. So when you define or you deploy your Kubernetes cluster, you have a system administrator that usually knows everything about your storage system. So it defines different storage classes. And say you have a fast but very expensive, and we have slow and very cheap storage classes. And as a developer, you decide, okay, so I need to use as fast as possible. So I'm submitting this persistent volume claim. So this persistent volume claim is essentially it's another resource that defines, okay, for my application, I need to use a persistent volume with such and such size of this. So that's why this Kubernetes will provide you with persistent volume of particular class, and this will be attached to a particular pod, and this is what's created this bind between persistent volume claim. How it works in terms of how it interacts with the kube node and the kube controller. Usually, controller requires from the storage system, whatever storage system is there, to attach volume to a particular node. It can be in real life. It can be the kind of software solution, or it can be hardware solution. So there will be kind of directly attached, or there will be a network attached system. And after that, the particular Kubernetes node will be requesting this volume to be attached, and the volume will be attached a special mounting point on this kubelet, and after that, this kubelet will allow to, and in this case, kubelet will be responsible for attaching a particular mounting point inside the pod of your application. But still, we want to run the Kafka application, and during the time when there was no cell phones, there was no phones at all. The way how you communicate, you need to call or pick up your the phone and ask if you want to connect. If I want to call James, I just want to say, hey, can you connect with James? And I don't know what funky business will go on there. I don't know anything about the things what this lady will do, but all of a sudden I have a connection to James. And this is what essentially what is happening in this currently. All the software start using this pattern called operator. So essentially, you don't really care what funky business this lady would do, but it will make things happen, right? So if I want to call her and say, hey, I need to deploy this Kafka cluster, just please do. And she's going there and deploying stuff. So this is what we took out of our cloud offering, and we just make this as a product that people can use and install in similar pattern, right? The things that we just want to have a bunch of resources who want to make this native to Kubernetes, and some of the things that will go on, we really, because it's easy to automate, and this stuff will be simply running. The custom resource controller, this is a small container. It's another container. Everything is in Kubernetes is a pod. So it's a small pod that runs your code, and if something is happening with this custom resource, that this custom resource container is listening, this would be sent to certain handlers, and these handlers will be responsible for make some decision based on this, right? So it's the kind of event.
Is that operator and custom resource definition, is that available if I wanted to run it myself?
Yeah. So this demo actually like downloads everything. So the way how it looked like.
So it's all open source.
It's not open source, but it's like available to you if you want to use it. Operator is not available. All these Helm charts definitions, how we can run this in the dashboards, open source. The operator itself is not open source.
Okay.
Images that we use open source. All the stuff is open source except the operator itself. It's part of Confluent platform.
Yeah.
But the operator you run inside of Kubernetes,
Yep.
the Docker image is available.
No, the images itself, it's published on Docker Hub. So images there, but it's just
But it's just a binary block.
binary, exactly.
I'm reading. Yeah, I'll post the deployment instructions.
Yeah, so the way how it's, if you go to this, where is it? We have this GitHub, Confluent, a demo scene. So this demo is just designed to be run on GCP, but because it uses some of the GCP related commands, there's a Twitter streams operator, which is like one command basically that you need to run is the make file has this like a make demo, and it also can create GCP cluster for you. So it will download operator, Helm charts. So we're using Helm charts over here to deploy our custom resources. If, for example, I'll give you idea, for example, for Kafka, it doesn't have this things related to stateful sets and stuff. It has this Kafka custom resource, like this Kafka cluster, and certain values. So this is where I think some of the knowledge that we gain from the managing this stuff is comes into play. We know that which is important, which is not, because Kafka by itself has like a gazillion of the parameters that you can configure. The things what you really care about, how many nodes and what kind of storage you want to have. And once you have the storage, and the storage definition is usually something that we define in where's my values demo. Yeah. For this demo, I'm just using this. I'm saying that this provider GCP and the operator knows what specific like APIs and what specific things to call since it runs on GCP, what kind of storage to provision, and where is it? There should be something like where exactly running. I can also specify zone, but I think it just uses whatever by default is in my GCP and kube config file. So this is why I'm not specifying this. But you can also deploy this in the multi-zone deployment if you like. Okay, so let's see if actually it works. Let me port forward 8080. So I will try to see if anything of it is actually working. This is where I'm running my small tiny thing key SQL, and here I'm running key port forwarding control center, port forward control center 9021. See if I can if I see this UI that my broker is up and running. Yeah, broker is up and running. Something is going on. Connect cluster is here, so Twitter is up and running. So we can see if we can get any data here. So I can do this with KeySQL. So KeySQL has a server side of thing and the client side of thing, and the client communicates to server through HTTP. Like if you ever use things like SQL Plus in your Oracle or any type of PG Manager type of thing, so it's like a similar thing. So it has show topics. I can see if I have stuff here. So topics are here. Now let me create a stream. Interesting thing. Let me actually show this first. If you do Set offset. So when I said the Kafka is different from the messaging system, is that like you can always replay all the messages that come into Kafka. So there is a concept of offset, which is basically your bookmark that you're putting in the book when you're reading. When you're sharing this book with others, you know that your bookmark is yellow, and you know that you can continue to reading things from the point where you stopped. So when I reset this offset, meaning that I starting over. So in this case, I want to make sure that my data will be at its fullest because I didn't run any processing before, so I'm starting this one. So I'm creating this topic that I will collect on this all the tweeters that coming from Twitter Firehose. And the way how I configured this, as far as I remember, this why we did this. This should contain my my Twitter handle. So let's see if we will be able to do that. So, and I will do, okay, great. For example, I can create a specific tweet that will contain information only about Kafka Summit or any other thing. So you want to grab like particular hashtag, or let's do something like like this. So in this case, whatever will be text that will include my Twitter handle and Ren's hashtag will end up in this Twitter feed. And now I can do things like what is this? Okay, tweets. Okay, let's see if I can do this. If you don't have Twitter, it's okay. This is what we're Russian known of, that we're creating a bunch of fake Twitter accounts to tweet about stuff. So let me do this for you. I can say is talking to things on this hashtag Kubernetes. Okay, this. Cloud native Meetup. Okay, I'm doing typos, so that's why I have the right tools to fix me, so I will not sound like real Russian here. Actually, Kafka, Franz Kafka, he's from Czech Republic. Let's see if we will get something here. So again, Twitter Firehose, Twitter goes there in the cloud, just goes to Twitter Firehose, and it's a good thing we can do this print Twitter JSON 01 from beginning. See if we have any data. Yeah, actually, it works at getting some of the data, but let's see why it didn't arrive to my thing. So probably I know exactly, because the case, some of the stuff around.
You lowercase the tags, but then you use an uppercase K and
show streams. Yes, but let me see if I actually using the right command. So in this case SQL tab, I also can see this running queries, and I can see, okay, it runs once. Where is the second one? I don't see the second one. Twitter row, hashtag entries. Okay, streams, Twitter row. Let's see if we have everything that we need. I don't see if I do this right. Okay, describe, extended, and let's see Twitter row if I do this correctly. Create stream. Okay, I can always drop it, so I will do drop Twitter. Let me start over. So it's this why stream Twitter. Let's use capital. Twitter. I need to kill. Okay, this is something that annoys me a lot. I need to terminate this query. So the way how this KSQL works is actually, working on data that arrives. So this is what there would be two types of queries. One is a persisting query. So this is why there's some of the query that will be running in the background. I will just drop stream. Can I do this? Twitter, and I can do drop stream Twitter raw. Okay. Okay, let's do it again. And I'll do this one. Actually, two. So let's see if I. Yep. All right. So we're looking at data is here, and data is fine, and that should be. If I do select star from Twitter raw, we should get some of the data. Let me try to do this again. Twitter will not allow me to tweet this. This is why there's a thing that allows me to do that. Yeah, something is going here. See, so it actually works. Now, second thing is that like all these tweets is going here. I'm interested only select star, select, and what kind of we have properties here. Twitter raw. Let me see describe. So what kind of properties I might be interested in? This here text and let's do user. So we can do select text, select user and text from Twitter raw. And this should be, yeah, we're getting something. So we're actually getting something.
Okay, that's the tweet I just tweeted.
Fantastic. Okay, so we actually in business, right? So there's two types of query. One is constantly running, so we're getting this data into this topic, and we can do this select. And this select will be running only when I will be running this this query. But I am interested in some of the constantly running things because I want to have like a constant computation. So let's see how we can continue to do this. Where's my streams? Let's do this. Let's just do everything. Yeah, we will need to do this. We're creating this very structured stream. So we have a bunch of stuff here because our connector dumps just a pure JSON that comes from the Twitter API. Now we want to extract certain fields so it will look like a normal data that we can operate with. So in this particular case, this KSQL has certain operations that work with JSON. For example, I can extract certain fields using JSON path and store this as a particular field.
So you've got incoming streaming JSON, and KSQL is transforming it into
whatever you like, whatever sort of format. Yeah. Okay. So we're creating this stream, and now if I do select user and text from Twitter, so there should be something more or less human readable. And in my case, okay, we don't have user. What username? Sorry. Username and text. Okay, we should get something because again, see, someone is tweeting something, and as you can see, there's some Russian collusions going on. So, apparently I'm popular on Twitter, so this is why people are tweeting about this in this time, which is like pretty late in Russia. But let's keep this running because I want to show this some of the the processing aspect while I'm doing my operations aspect. So now I will do a very cool thing. I will just do edit Kafka. This is how you do this in production, right? Just go there and change your resource in line. How many of you doing this actually? Like you can go change resource and I love this. I'm doing this all the time. Like, why use Helm? Like, Helm will just create another release. Everything will be bounced. Like, just go. Let's get this cluster bigger, right? I want to have my Kafka cluster with more nodes, so it is going to starting another container, and during this time, my control center should be able to demonstrate me something like a broker uptime. So we should be able to see one of the nodes will go up. And the cool thing about this, if you will change this stateful set, so stateful set will rolling, will bounce and roll all the pods in this set. Depends on the policy, of course. In this particular case, because this resource was served by operator knows that certain operations I can do without bouncing all these components. So in this case, I'll just go ahead and change configuration, and one of the Kafka brokers will join my cluster without downtime. And this particular is still not running. And the cool thing I can always get is from this get Kafka, I can get status always. If I go here, it still says running, but it should say provisioning as far as I remember. Maybe it's already done. It's maybe much faster. Yeah, because it's already done, it's much faster than my watch command that refreshes every 2 seconds. So my control, wow. What the hell is this? But essentially what I was trying to show is that it's actually number of brokers will go, oh, okay. So this is a front end. Front end is hard, you know. This is why we're doing backend, and there's special trained people who receive ridiculous money for writing front end. Another cool thing is that because operator knows. Okay, let's see if our tweets are still going. Let me see. So and tweets. Come on. Tweet processing is still running. You can participate if you want to see your tweet on the screen. Okay, so is someone just Twitter? CJ? Who's CJ? Oh, cool. Thanks for your support. And this is my Kafka. So see, it's still running. Someone. Okay, so there's some of the political tweets here. There's a joke. Okay, so I will explain you since you will see all these tweets here. So this morning I started like small flash mob in the Russian segment of my Twitter. Is that basically there's a joke that on the conference two say Kafka engineers meet, and one engineer asks another engineer how to do exactly one processing with Kafka. Another one replies, I can tell you how. And second one replies him back, I can tell you how as well, but how I can do that. So it's kind of like a kind of joke. And now it starts like a recursive joke because people start tweeting about this like DevOps joke, the JVM engineer meet, and there's like tweeting about something. And now they have this some of the jokes around two libertarians meet each other and asking how can build a beautiful Russia of the future and this kind of stuff. So this is why you see some of the Russian tweets in this Twitter line. So, but still pretty cool. Now, while we're chatting, our cluster can do something useful. For example, he edits Kafka. Useful thing. Sometimes you see software might have bugs, and you realize that you should deploy something that might have bugs, so you need to do rollback. But technically, the way how I do this, why I need to do rollback, because I'm always forgetting that I need to show kind of upgrade. So I need to start with previous version. So in order to show you how I can upgrade the real time, I need to do downgrade first. So doing this downgrade, and now operator knows that it needs to bounce the cluster in the certain order, and the order is like this. The Kafka, one of the Kafka brokers is actually more important than others. It's called Kafka controller. And only way how you would know what's the controller, you need to either call API or you need to go in Zookeeper and ask Zookeeper what particular node is currently a controller. Controller is responsible for making sure that other nodes are not misbehaving. So controller responsible for leader election that happens inside the Kafka cluster. So also it replicates the partition and cluster structure from Zookeeper. So that's why we started using Zookeeper less and less because it was causing more and more trouble. So that's why controller taking responsibility for handling some of the hard stuff. Now, should you kill controller first during your running state? Absolutely not. I'm quoting Leonardo DiCaprio from The Wolf of Wall Street. You should not, because the time that will take you to restart the process will be increased exponentially, because another leader election must be happening, and plus because some of the node is leaving cluster, some of the node is going into cluster. This stuff might go into very nasty and unpleasant situation where you have not enough nodes to perform like in-sync replicas and things like that. So this is why controller needs to go last. Now, this process will take some time to restart. I can show some other slides. So what is happening underneath? We're still using all these underlying building blocks, but we use those like in API fashion. There's a Kubernetes API, it's pretty cool. There's a Go client available, so you can programmatically interact with this API. It's pretty nice. Like the writing some of the operators these days is relatively, if you know Go language or any other language, you can write your operator in any language essentially, because Kubernetes really don't care what you're running, as long as you're running this in container, as long as you're running this in the pod. And it can be, there's operator for Kafka written in Java, our operator written in Go. I'm doing some POC to write some of this stuff in Kotlin. It doesn't matter, because again, we're returning to this idea that Kubernetes is a modern distributed operating system, and what kind of language you use to write your application doesn't matter, as long as this final result would be a pod. Now, a little bit about how it's going on from perspective of interacting with operators. So we have this the Kubernetes API server, this guy. So on the top, where's my pointer? Doesn't work. So this guy on the top. We using kube control, but it can be Helm charts, which is usually the same thing, or we can call this API directly. Some of the calls will be submitted to API server, and after that, this API server will broadcast this event, saying, "Hey, this is some changes of this particular resource happen," and there might be some internal, like the things that Kubernetes developers provided. Controller, for example, for pod controller will be responsible for handling some of the pod things. But in this case, we'll have our customer source controller, which is watching a Zookeeper and Kafka resources. And also, it is responsible for looking for other resources in this particular physical stateful cluster. So let's take a look how this physical stateful cluster look like. So if I go here, we just do get physical stateful cluster, and let's look at KSQL, for example. This is kind of cool stuff. This is why I love YAML so much. Actually, I'm not. So you have a YAML and you have a JSON inside YAML. How cool is that? But the good thing is that the actual people don't write this. It's like a machine-generated thing. So we do have some of the preprocessing stuff that happens here, and this is what we're providing. A configuration that related to interacting with this Kafka cluster. Remember, if I will show you the Kafka resource, it has very interesting thing here. It has this kind of sort of connection string, right? So we also expose information how the clients can connect to this cluster. So this is why just going and interrogating this resource, I get information about security and the connection to this cluster. For other things, like if we need to programmatically configure security for this cluster, we also support this, and we can inject some of the certificates and keys in order to establish TLS communication between Kafka broker nodes, or provide the external access to the client through TLS. We also, same way, it will be available to external clients through customer source definition. Let's get back to it here. So all this stuff that we'll see here in terms of how to connect, where is it? Yeah, this bootstrap server information. It was injected from the previous resource. So we know that we have this the Kafka cluster resource, and in order to KSQL to connect to this Kafka resource, this information needs to be injected. And there's tons of crap here that you as a person don't want to configure. Only thing that you're configuring is essentially where's the values? This is our values file. So you're saying here you want to have Kafka cluster with certain resources. Load balancer is disabled, but if I will enable, I will be able to also provision the load balancer that will expose all the broker nodes to outside world, so you will be able to connect from any local from anywhere in the world. Same thing with other components. So this is where I'm specifying. So this is my KSQL. The only thing I'm specifying here that this is going to be my endpoint, and I know that there are going to be 3 brokers. That's it. So rest of the stuff will be handled by operator, and security here, again, obviously because security is important, I'm not using it here. So let's see if our cluster is successfully bounced. Yeah, so we successfully downgraded this cluster. So this is why you can trust me that upgrade also will work similar way. If I'll go here, you see where's the generation? Yeah. So I did 3 things here. I extended this resource, so I added the 4 replicas. I changed the image right now. Let's see if our tweets are still coming. Yes, the tweets are still coming. So Kafka is up and running. And the third thing that we can do, like we can continue to do, like scaling this up and down, and so far and so on. But we won't. Now, in terms of deployment, how it works, all these images are in Docker Hub. They're there. We also post all this GitHub, where is it? GitHub.com, Confluent, CP, Docker, images. All these images here, and the images are open source as well. All these images here go here. For now, we're using Debian as our base image, but we're also working on kind of certification on OpenShift, and OpenShift images needs to be RHEL or CentOS based. What we're looking at is to support how they call it, universal something image. They define format that allows to, rely on their release cycle in order to get updates and stuff like that. For now, we're providing Helm charts to deploy this. You still can use things like, there's a project that kind of sort of helping to look after CP, Helm charts. This is our first attempt to show people how they can deploy stuff in Kubernetes. So the Helm charts, this is something that, where is it? Charts. Same thing that we just discussed, Kafka, you can deploy KSQL, control center, all these things can be done. But in in my actual charts, we use this like standard building blocks. We're using stateful sets, we're using services. This is very good if you're just starting with Kafka and Kubernetes, just need to deploy, play around with this. You don't plan to go with production with this because it doesn't have any maintenance operation knowledge. Like it doesn't know how to do rolling restarts. It doesn't know how to do upgrades correctly. Though like all this stuff can be done by adding things like, that's why I love YAML so much, because you can do things. Where is it? Some of the shell scripts I really love to see when this kind of stuff. Like you're using this declarative language to define your deployments, and after that, just you go crazy with the shell scripts. In Operator, we're using slightly different model. We're using the init container, which is another option to add extra container inside your pod. And yeah, we support all the major providers, and we support OpenShift Pivotal. This is what I know personally when I run, because I run this in OpenShift and Pivotal. Next week we're doing this Spring 1 event where we're talking about like how the people can deploy this in Kafka on Pivotal container service and deploy your apps on Cloud Foundry.
So it's question.
Yeah.
When you deploy that,
yeah,
is it into my AWS account or is it into a Confluent?
No, it's yours. Yeah.
It's my, okay.
Yeah. So in this case, I just use my. This is my. Kubernetes.
Oh no, I was talking about the Confluent managed.
Okay, so this is different. So there is if we're talking about this.
Yeah.
We deploy this into whatever zone you want to deploy, but we manage this cluster for you.
Gotcha.
With Google, we have a better integration from perspective of like if you're using GKE and you also you can deploy this from Google UI. Supposed to, and also you will get the bill from Google. With Amazon and Azure, you still have this like the bill from us. But we manage your infrastructure. You just say, okay, I want you to run in this zone because my apps run in this zone or in this region, and we will be able to do so. But we manage this for you. We manage fleet of Kubernetes cluster, and we'll make sure that to place it where you want. All right, so a little bit about the rolling restart. I talked a little bit about, so there's a process of partition reassignment. This process is not complex, but it requires to be performed in a certain order. And like just listening to particular metrics, they also expose that we can start upgraded broker. Under replicated partitions, this is the most important metric that can talk about the health of this particular cluster and update the next broker. Scalability. Here's one problem right now with scalability. So because adding one more broker is not a big deal actually, and this is why we don't roll the whole cluster if we're adding one more broker. So when you add a broker, you actually want to redistribute your Kafka topics across this, so you can use more capacity. So this is why. But this process is not something that you want to do just like using this auto-scaling capabilities of Kubernetes, because it is sometimes clusters can have a lot of data. You just don't want to start in the middle of the workday, start migrating massive amount of data between systems. We have this tool called Auto Data Balancer, but it's not technically auto. You need to it automatically understands partition distribution and will execute more efficient plan. This is what about automatic. But we actually, in our cloud, we're already doing automatic rebalancing, and this is something that we will be shipping in Operator too. So the same stuff will be available into Operator. And the monitoring, the control center will be used. One of the things that I also, with another my friend who started working on this, because we don't like YAML, So we start looking into this thing called the Kotlin DSL for Kubernetes. In this case, how you can use this to deploy things like Kafka, and this actually is pretty cool. So this is how this DSL would look like. So that allowed me just simply define like metadata for my clusters to spec and code completion and the validation of the things will be happening flawlessly. Let me actually show you quickly what I'm talking about. Where's my content user example? So like when I say like typing things, let me just give you an example here.
Is that a NANDCAT plugin for IntelliJ?
Yeah.
No, I'm downloading tomorrow.
Do it today. Just why wait until tomorrow? So it understands. So we generate all this DSL based on customer source definition. If I'll do say zones and I say US West 1B or something like that, right? Yeah, code completion already automatically shown because it's expecting a list of things. So in this case, I just provide one list of this one, and I can do code completion. I know exactly where I am, what things the JVM config. And JVM config, which is an object, I think that has another things like actually was it GMS? Yeah, it should be JVM config, and I can define property like heap size. I can define properties like what is it? Some of the JVM parameters and so far and so on. So I think it is pretty cool. So actually I'm doing this, and I will do something like, can I do this? No, not the extension function. Stupid. JVM config, and what is that expecting? JVM config, and I can put heap size, which is 2 GB, something like that. So this is something that I'm personally looking, and maybe like some of the examples that I will, build maybe small operator that will use this API to interact with my operator and to use this at its fullest. Let's see if we're still running. Yeah.
So is that Kotlin thing? Is that a configuration language itself, or does it compile
Okay, so
down? How does that?
Yeah, the Kotlin itself, it's the full-blown programming language.
Right.
So it has everything that Java has, everything that Scala has.
So this thing
Yeah.
compiles down to a binary,
Yeah.
and it actually talks to the.
Yeah. So, for example, you're writing your app, and next to your app, you're writing your deployment in the same language you have. You're writing this. It's actually a lot of things that. Where is it? Kotlin DSL. Yeah. So this is library that we just went and interrogate this the customer source. So, for example, let's not talk about customer source yet. Let's talk about standard Kubernetes, for example. So in order for me to write something like, there should be example of regular base deployment, for example. Forget about Kafka for a moment. So when you need to write the deployment of this service that has a spec where you put in your, all this all the things that you need to put in the spec definition, what kind of containers you put in here, image. And the cool thing about this, so since it's the real programming language, you can use all constructor programming language, you can use any library of the program range. If you don't like templating language that Helm provides you, which is Go template, you can use this kind of stuff, or you can use Mustache, you can use Handlebars, or whatever you like. So you can use the standard the template that built in the language. The way how it works.
Is it converted to YAML?
No, it's actually
We talk directly to the Q's API.
Yeah. So it has this underneath. There's a client that talks directly. So if you're talking to kubectl, it's essentially executing gRPC calls to your Kubernetes cluster. And if you will look inside the code of your kubectl, it's actually some network client that talks to your gRPC. Same thing there. There's Java client that we use here for Kotlin DSL. This Java client talks directly and makes these RPC calls to your Kubernetes cluster. So it doesn't generate YAML per se. It just does same thing that your kubectl does.
Is there a way with this to, at runtime, dynamically determine which configurations to include and use if you have like multiple configurations in different configuration files?
Give me an example why you
So
want
let's
to do
say
this.
I have a base.
cluster versus the development cluster.
Yeah, let's say I've got a base configuration and then I've got like a separate file that has just dev specific stuff and then QA specific stuff and then.
Yeah, so as you can see here, we have this like a base deployment, and it actually extends deployment. So deployment, this is your Kubernetes deployment thing. But right now I'm just looking into decompiled code. But my base deployment defines like I'm extending everything that comes from deployment, and after that you can extend this into production deployment, QA deployment, and like whatnot, right? You can define some of these kind of things, and you can say like maybe it's overkill to use like a full-blown programming language for this kind of stuff. But the thing about this, like, it gives you more flexibility. The tools exist and already natively support all this language. Like for example, IntelliJ Community Edition, free version, supports this out of the box, works amazingly, and it's compile time thing. It does during compilation and checks that you're not doing anything funky, so you don't need to kind of similar thing that you can say you can do with Helm, but also doesn't require any server-side component. Can use whatever templating languages you want. Maybe you also want to include some, like you're writing this deployment, you're fetching some of the additional information from your CI/CD pipeline, like some of the other artifacts or some of the other information that you want to include in your deployment. You can, after you've done this deployment, you can also programmatically, trigger something else, trigger some of the pipelines. So there's a lot of things, like the TeamCity, for example, which is JetBrains, like CI/CD tool. It has like a Kotlin DSL to define pipelines. So same way you're using Groovy in your Jenkins pipeline, the Kotlin used in TeamCity. So only difference that Kotlin is statically typed. So in this case, during compilation, you will be able to spot some errors where sometimes I'm looking into this YAML and don't understand, like, should I use this map here, or it's just or it's a list of properties. I'm not good at YAML, or like I'm not good on indenting YAML specifically here. Since my DSL, I can, this bothers me. Let me do not show hints. So in this case, it looks very similar to YAML. However, without, like personally, I hate when the indentation happens using the tabs or spaces. I prefer like the brackets. So in this case, it looks like a pretty nice deployment thing, right? And this is just simple deployment of Ingress. Also, you see, this is where we're interacting with the with client that talks to our Kubernetes, and this information is actually taken from home/.kubeconfig. So it also works in the same things that you already use. If you're using multiple clusters, you can change what kind of cluster you want to connect and things like that. So it's quite awesome if you ask me. So we took this like a basic thing with the standard Kubernetes APIs, and after that generated the where is it model? So and we generated all the resources that this custom resource included. And we actually generated this in a pretty cool way. When you just talking to some Kubernetes API, you actually can get the schema out of custom resource. So you take the schema, you parse it with some of the tools that also, I believe there's some tools that Red Hat guys use to parse the schema and turn it into Java objects. And like, where's my Kafka cluster? Yeah, there's my Kafka cluster, and there's all sorts of annotations because I guess the source of this custom resource schema is also JSON. So that's why it knows how to map the JSON data into actual Java poetry or things like that. So all this, it's basically all these classes are automatically generated, and a result of this is the, where is it? Yeah, where is it? Yeah, so the result of this is something like this. So deployment can be here. And it's not only for deployment. You can also go and get the, so in this particular case, I can do, this is where I am not deploying, I'm introspecting this information. For example, I'm getting this information about Kafka cluster resource, or I can do client deployments, client, namespace. How we can get, let me see, how we can get this deployment thing. Base deployment. And how I execute this. Client extension. Okay, client extension. So if I will do things like client extensions. Why it's not there? Default Kafka client in namespace. Okay. Let's see. Things like Kafka client, default Kafka client. Why can I get namespace? Namespace also returns what? Namespace Kafka client and things like that. So yeah, this is pretty cool tool. I think that would be it. We do have a Slack. If you have any sort of questions around Kafka and Kubernetes, we do have a Slack in Confluent Slack. There's a lot of people asking about all sorts of questions about Kafka. I'm looking to this one, Kubernetes chat there. Yeah, I did this presentation together with the on the Kafka assignment with Michael Ink. He's product manager for Operator at Confluent. And that would be it.